Hello, in this lecture we will find the radius of a circle. As you can see in the drawing, we have a circle. Chord AD of the circle equals to 10 units. Chord BC of the circle equals to 5 units. The center of the circle is at point O, and this angle equals to 90 degrees, and we want to find the radius of this circle. Okay, first of all I will define what is a peripheral angle. Okay, so actually a peripheral angle is actually an angle that its vertex is on the circle and its curves are chords or strings in the circle. So I will read the definition of a peripheral angle. A peripheral angle is an angle that its vertex is on the circle and its curves are chords or strings in the circle. So, for example, angle alpha is a peripheral angle because of the fact that its vertex is at point A, and point A is also a point on the circle itself, and the curve AB of angle alpha is also a chord or string in this circle, and curve AC of angle alpha is also a chord or string in this circle. Okay, so a peripheral angle is an angle that its vertex is on the circle. The vertex of angle alpha is at point A, that is also a point on the circle, and the curve AB of angle alpha is also a string or chord of the in the circle, and curve AC of angle alpha is also a string or chord in the circle. Okay, so actually that is the definition of a peripheral angle. Okay, so we will draw a chord through points A and O of the circle. You should remember that point O is the center of this circle, and we will draw a chord through points A and O. Okay? We will call to the touching point between the chord to the circle point M. Actually, chord AM is the diameter of this circle. Okay? Chord or string, it is the same thing. AM, this chord is the diameter of this circle. Because of the fact that chord AM passes through the center of the circle, that is to say, chord AM passes through point O, that is the center of this circle, it is defined as the diameter of the circle. Okay? Because chord AM passes through the center of the circle. That is to say, from point O, that is the center of the circle. Okay? So, chord AM is the diameter of this circle because chord AM passes through the center of the circle, that is to say through point O, that is the center of the circle. Okay, AM is the diameter of this circle. Okay, in the next step we will connect together points A and D, points M and D by a straight line. Again, we connected together points D and M by a straight line. Okay, we actually have rule number 1. Rule number 1 states that a peripheral angle that rests on the diameter of the circle equals to 90 degrees. So I will read rule number 1 again. Rule number 1 states that a peripheral angle that rests on the diameter of the circle equals to 90 degrees. Again, a peripheral angle that rests on the diameter of the circle equals to 90 degrees. Now I will give you an example what rule number 1 means. If AB, if string AB is the diameter of this circle, then any peripheral angle that rests on this diameter equals to 90 degrees. So if we have so actually the angle in the right side rests on AB, that is the diameter of this circle. So according to rule number 1, it equals to 90 degrees. It is a right angle. Okay? And even if it is in the other side of the circle, for example, the angle in the black color rests on AB, that is the diameter of this circle, and therefore, according to rule number 1, it equals to 90 degrees. Okay, so any peripheral angle that rests on the diameter of the circle equals to 90 degrees. This angle rests on the diameter AB, therefore it equals to 90 degrees, and this angle also rests on the diameter AB, therefore it equals to 90 degrees. Okay, so actually angle MDA angle or MDA or ADM angle ADM or MDA, it is the same, rests on the chord AM, that is the diameter of this circle. So according to rule number 1, angle ADM equals to 90 degrees. Okay, so angle ADM that rests on the diameter of this circle, that is to say, rests on chord AM, that is the diameter of this circle, equals to 90 degrees according to rule number 1. Okay? According to rule number 1. Okay? Angle ADM equals to 90 degrees according to rule number 1. This angle equals to 90 degrees according to rule number 1. Now we will focus on right triangle ADM. So on the right triangle ADM, we will define angle AMD as alpha, angle AMD will be defined as alpha AMD. Angle AMD equals to alpha according to our definition. Okay, according to our definition, angle AMD in the right triangle ADM equals to alpha, and angle AMD will be defined as beta. Angle MAD will be defined as beta. Okay, angle AMD equals to alpha and angle MAD equals to beta. This angle equals to alpha and this angle equals to beta. Okay, and we actually know that in any triangle, the sum of the angles in any triangle equals to 180 degrees, especially in the right triangle AMD, the sum of its angles equals to 90 degrees. So I will write it down. Our first equation will be the sum of the right triangle AMD, that is alpha plus beta plus 90 degrees, equals to 180 degrees. It is true for every triangle in the world, especially in the right triangle AMD. So we created equation number 1 that states that the sum of the angles in the right triangle AMD equals to 180 degrees. The sum of the angles of the right triangle AMD equals to alpha plus beta plus 90 degrees, and it is equal to 180 degrees. As you can see from the drawing, the sum of the triangles AMD, the right triangle AMD, equals to alpha plus beta plus 90 degrees, and the sum of the angles of any triangle in the world equals to 180 degrees. Okay, now we will subtract 90 degrees from equation number 1. We will get that alpha plus beta plus 90 degrees minus 90 degrees equals to alpha plus beta, and 180 degrees minus 90 degrees equals to 90 degrees. Okay, I subtracted 90 degrees from equation number 1. Alpha plus beta plus 90 degrees minus 90 degrees equals to alpha plus beta, and 180 degrees minus 90 degrees equals to 90 degrees. Now we'll subtract alpha from both sides of the equation, or we'll subtract alpha from equation number 1. We will get that beta equals to 90 degrees minus alpha. Okay, we subtracted alpha from this equation. Alpha plus beta minus alpha equals to beta. 90 degrees minus alpha equals to 90 degrees minus alpha. So beta equals to 90 degrees minus alpha. Okay. Now we will connect together points A and B by a straight line. We have another rule, I will call it rule number 2. According to rule number 2, if two peripheral angles or peripheral angles that rest on the same chord slash arc equal to each other. Are equal to each other. So I will read rule number 2 again. Peripheral angles that rest on the same arc or chord on the same chord slash arc. Okay, peripheral angles that rest on the same chord slash arc equal to each other. Okay, so I will give you an example what rule number 2 means. Actually, if we have chord AB and we have two peripheral angles, one peripheral angle rests on chord AB, we will call it alpha, so angle alpha rests on chord AB and we have another peripheral angle beta. angle beta also rests on the same chord AB. According to rule number 2, alpha equals to beta. Because of the fact that those two angles rest on the same chord, that is to say, they both rest on chord AB, they are equal to each other. Okay? According to rule number 2, they are equal to each other. Angle alpha equals to angle beta because of the fact that both of them rest on the same chord AB. Okay? So if two peripheral angles rest on the same chord, then they are equal to each other. Okay? For that reason, alpha equals to beta because they both rest on the same chord AB. Okay? So we actually can implement this rule in our circle. We can implement rule number 2 in our circle. Actually, angle alpha, that is to say angle AMD, that equals to alpha, rests on chord AD. Angle alpha rests on chord AD. On chord AD of the circle. Okay? Angle alpha rests on chord AD of the circle. Okay? Angle alpha equals to angle AMD, and it rests on chord AD of the circle. But angle ABD also rests on chord AD. Okay, angle ABD also rests on chord AD. Okay, angle ABD rests also on chord AD. So angle AMD that equals to alpha rests on chord AD, and angle ABD also rests on the same chord AD. So according to rule number 2, they are equal to each other. So this angle equals to this angle because they both rest on the same chord AD. So actually we can say that angle, according to rule number 2, angle ABD also equals to angle alpha, because they both rest on the same chord called AD. Okay, so angle ABD also equals to angle alpha, because they both rest on the same chord called AD. Okay, so actually angle ABD equals to alpha. So in the right triangle, we will define this point as point L. Okay, this point is defined as point L. So in a right triangle ABL, we will define angle BAL as X. Okay, this angle will be defined as angle X. Okay, in the right triangle ABL, angle BAL will be defined as angle X. Okay, in the right triangle ABL, angle BAL is defined as X. Okay, and we know that the sum of the angles in any triangle equals to 180 degrees, especially in the right triangle ABL. The sum of its angles equals to 180 degrees. So we will create the second equation that states that the sum of the angles in the right triangle ABL equals to 180 degrees. So alpha plus X plus 90 degrees equals to 180 degrees. So actually this is our second equation that states that the sum of the angles in the right triangle ABL equals to 180 degrees. That is to say, alpha plus X plus 90 degrees equals to 180 degrees. Okay, now we will subtract 90 degrees from both sides of the equation. Equation number 2. Oh, okay. So we will get that alpha plus X equals to 90 degrees. Okay, we subtracted 90 degrees from equation number 2. Alpha plus X plus 90 degrees minus 90 degrees equals to alpha plus X. 180 degrees minus 90 degrees equals to 90 degrees. Now we will subtract alpha from equation number 2. So we subtracted alpha from equation number 2. X plus alpha minus alpha equals to X. 90 degrees minus alpha equals to 90 degrees minus alpha. So x equals to 90 degrees minus alpha. This is our second equation. But according to equation number 1, beta equals to 90 degrees minus alpha also. So we will write it down. So according to equation number 1, beta also equals to 90 degrees minus alpha. Okay, so we can deduce from both equation number 1 and 2 that x equals to beta, or I will show you the long way. 90 degrees minus alpha equals to 90 degrees minus alpha. Okay, then we can subtract 90 degrees minus alpha from this side of the equation by x, and we can subtract 90 degrees minus alpha from this side of the equation. We can substitute 90 degrees minus alpha by beta. Okay, so we will get that angle x equals to angle beta okay, we got that angle x equals to angle beta. So actually, instead of x, I will write beta because x equals to beta. Okay, x equals to beta, so instead of x, in the right triangle ABL, I wrote beta because x equals to beta. Now we have rule number 3. Rule number 3 states that equal peripheral angles rests on equal chords. Chords or slash arcs. I will read rule number 3 again. Rule number 3 states that equal peripheral angles rest on equal chords/arcs. So I will give you example in order to clarify rule number 3. So if we have two peripheral angles, as you can see in the drawing, we have two peripheral angles that both of them equals to alpha. So according to rule number 3, we can deduce that they rest on equal chords. That is to say, AB equals to CD. Okay, because of the fact that those two peripheral angles equal to each other, both of them equals to alpha. According to rule number 3, they rest on equal chords or arcs. That is to say, chord AB equals to chord CD. Or we can also say that arc AB equals to arc CD. Okay, but for this question, the main equality that we are interested in is that chord AB equals to chord CD, because of the fact that those both two peripheral angles equal to each other, they rest on equal chords. That is to say, chord AB equals to chord CD, according to rule number 3. Okay? So, equal peripheral angles, if two peripheral angles equal to each other, then they rest on equal chords also. So, according to rule number 1, because of the fact that this angle equals to this angle, also AB will be equal to CD. Okay, so that is rule number 3. If two peripheral angles equal to each other, their chords also equal, they rest on equal chords. The chords that they rest on equal to each other. So AB equals to CD because of the fact that they both angles equal to each other, according to rule number 3. Okay, so Actually, we can implement this rule in our circle. As you can see from the drawing, we have angle ABL equals to angle beta, and angle MAD also equals to beta. Okay? So I will write it down. Angle BAL equals to beta, and angle MAD also equals to beta. Okay, angle BAL equals to angle beta, and angle MAD also equals to angle beta. Okay, both those angles equals to beta. So according to rule number 3, they rest on the same chords. Okay, so according to rule number 3, we can deduce that BC equals to MD. Okay, if two peripheral angles equal to each other, then they rest on equal chords. This angle is beta, and this angle is also beta. According to rule number 3, also BC must equal to MD. Okay? Because of the fact that those two peripheral angles equal to each other, according to rule number 3, they both rest on equal chords. That is to say, BC equals to MD. Okay? So because of the fact that those two peripheral angles equal to each other, they both rest on the same chords. That is to say, BC equals to MD. Okay? But we know it is given us in the question that BC equals to 5 units. BC equals to 5 units according to what is given us in the question. Okay? BC equals to 5 units because it is given us in the question. Okay? So we can deduce from it that MD also equals to 5 units. Okay? Okay, BC equals to MD, but BC equals to 5 units, so MD also equals to 5 units. Okay, BC equals to MD, BC equals to 5 units, so MD also equals to 5 units. Okay, so we can write that MD also equals to 5 units. Okay, according to rule number 3, equal peripheral angles rest on equal chords. That is to say, BC equals to MD, but we know that BC equals to 5 units, so MD also equals to 5 units. Okay, now I will draw the right triangle AMD again. So this is the right triangle AMD. Side AB of the triangle equals to 10 units. Side MD equals to 5 units. And AM is actually the diameter of the circle. It is also the hypotenuse of the right triangle. So I will mark it as D. Okay, AM equals to D. It is actually abbreviation for diameter, So we will use the Pythagorean theorem in order to find out the size of D. As I've already told you, D AM is that equals to D is the diameter of this circle. That is to say, it equals to 2 times the radius of the circle. So, according to the Pythagorean theorem, the square of the hypotenuse in a right triangle, of course, it applies only to right triangles. The square of the hypotenuse equals to the sum of the squares of the perpendiculars. So I will read the Pythagorean theorem again. Pythagorean theorem relates only to right triangles. So in a right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So we can implement the Pythagorean theorem in our right triangle. The square of the hypotenuse, that is to say AM square, equals to the sum of the square of the perpendiculars, equals to MD square plus AD square. This will be our third equation. Okay, the square of the hypotenuse AM square equals to the sum of the squares of the perpendiculars, equals to MD square plus AD square. But we know that AM equals to D, MD equals to 5, and AD equals to 10. So we can write it down. We can substitute AM by D, we can substitute MD by 5, and we can substitute AD by 10. Okay, we substituted MA by D, so it is MA square is D square. We substituted MD by 5, so MD square equals to 5 square. And we substituted AD by 10, so AD square equals to 10 square. 5 square is 25 and 10 square is 100. So in total we will get that this square equals to 125. Now we will take a root out of equation number 3. So the root of this square is D, and we have root of 125. But 125 equals to 25 times 5. 125 equals to 25 times 5. So I write it down. Okay, as I already said, 125 equals to 25 times 5. Here we can separate the root to two roots according to the rule that square of a times b equals to square a, the root of a times b equals to root a times root b. Okay, according to this rule that square root of a times b equals to root a times root b, so we can separate the root of 25 times 5 to two separate roots. So we will get that so we actually separated the root of 25 times 5 to two separate roots. It equals to root of 25 times 5 equals to root 25 times root 5, according to the rule that root of a times b equals to root a times root b. So the root of 25 equals to 5. Okay, so I will write it down. As I've already told you, the root of 25 equals to 5, so we got that d equals to 5 times root 5. But we know that the diameter of any circle equals to 2 times the radius. Okay? The diameter of any circle, d, equals to 2 times the radius. Okay? So, you can substitute the diameter d by 5 times root 5 because d equals to 5 times root 5. So we substituted d by 5 times root 5 because d equals to 5 times root 5. So we got that 5 times root 5 equals to 2 times the radius. Now we will divide the equation by 2 in order to find out the radius of the circle. So we'll get that the radius of the circle will be equal to 5 times root 5 over 2. Okay, so we divided the equality by 2. We got that the radius of the circle equals to 5 times root 5 over 2. So the answer to the question is that the radius of this circle equals to 5 times root 5 over 2. Okay, and if you want the answer in numbers, you can calculate it. So the radius equals to 5.59 units. Okay. So the radius of the circle equals to 5.59 units. Okay, the radius of the circle equals to 5.59 units. Okay, the radius of this circle equals to 5.59 units. Okay, now I will summarize the lecture. Actually, we wanted to find out the radius of this circle. We know that chord AD in the circle equals to 10 units, and we know that chord BC in the circle equals to 5 units. And actually the definition of a peripheral angle is an angle that its vertex is on the circle and its curves are chords/strings in the circle. Okay, so actually angle alpha is a peripheral angle because its vertex is on point A, that is a point on the circle itself, and the curve AC of the angle is also chord in the circle, and curve AB of the angle alpha is also a string or a chord in the circle. Okay, so angle alpha is a peripheral angle. Okay, and we actually draw a chord through points A and O, and the touching point of the chord with the circle is defined as point M, and actually chord AM is the diameter of this circle. Because of the fact that chord AM passes through the center of this circle, chord AM is defined as the diameter of this circle. Okay, so AM is the diameter of this circle, and we connected together points M and D by a straight line, and actually angle ADM rests on AM, that is the diameter of this circle. And according to rule number 1, a peripheral angle that rests on the diameter of the circle equals to 90 degrees. So because of the fact that angle ADM rests on AM, on chord AM, that is the diameter of this circle, according to rule number 1, it equals to 90 degrees. Okay, according to rule number 1, angle ADM that rests on the diameter of this circle equals to 90 degrees. Okay, now we will focus on the right triangle ADM. We defined angle DMA as alpha, and we defined angle DAM as beta. And we actually know that actually, I will repeat again on rule number 1, if AB is the diameter of this circle, then any peripheral angle that rests on the diameter AB will be equal to 90 degrees. So this angle rests on AB, it equals to 90 degrees, and this angle also rests on AB, so that is the reason that it equals to 90 degrees. Okay, so in the triangle, right triangle AMD, the sum of its angles equals to 180 degrees. So actually we can write that alpha plus beta plus 90 degrees equals to 180 degrees, because of the fact that the sum of the angles in the right triangle AMD equals to 180 degrees. So we got that beta equals to 90 degrees minus alpha. That is our first equation. And then we connected together points A and B by a straight line. And we actually have rule number 2 that states that peripheral angles that rest on the same chord / arc are equal to each other. So actually, if we have two peripheral angles, that is to say angle alpha and angle beta, that rests on the same chord, that is to say on chord AB, then according to rule number 2, because of the fact that they both rest on the same chord, they are equal to each other. Angle alpha equals to angle beta because of the fact that both of those angles rest on the same chord AB. Okay, for that reason they are equal to each other. Alpha equals to beta. Okay, so that is the explanation of rule number 2, and we can implement rule number 2 in our circle because we have angle AMD, that is angle alpha, that rests on chord AD, and angle ABD also rests on the same chord AD. For that reason they both equal to each other. So if this angle equals to alpha, this angle also equals to alpha because of the fact that both those angles rest on the same chord AD. So if this angle equals to alpha, this angle is also equals to alpha. Okay, so angle ABD equals to alpha according to rule number 2 because it rests on the same chord that angle alpha rests. That is to say on chord AD. So angle ABD equals to alpha. So in the right triangle ABL, we defined angle BAL as x, and we know that the sum of the angles in any triangle equals to 180 degrees, and especially in the right triangle ABL, the sum of its angles equals to 180 degrees. So we can write equation number 2 that states that the sum of the angles in the right triangle ABL equals to 180 degrees. That is to say alpha plus x plus 90 degrees equals to 180 degrees. So we got for equation number 2 that angle x equals to 90 degrees minus alpha, but we know from equation number 1 that beta also equals to 90 degrees minus alpha. Okay, so x equals to 90 degrees minus alpha and beta also equals to 90 degrees minus alpha. That is to say x equals to beta. So instead of x, we wrote here beta because x equals to beta. Okay, so angle BAL equals to beta and angle MAD also equals to beta. Both of those angles equals to beta. We have rule number 3 that states that equal peripheral angles rest on equal chords / arcs. Okay, so angle beta, this angle beta rests on chord MD. So according to rule number 3, this angle beta also must rest on the same chord, on equal chords. That is to say angle BC must equal to angle MD, or chord BC must equal to chord MD, because if you have two angles that equals to each other, if you have two peripheral angles that equal to each other, then they rest on equal chords. That is to say, chord BC also equals to chord MD. Okay, according to rule number 3, BC equals to MD because of the fact that both those angles equals to each other. Okay, this is example of rule number 3. If we have two equal angles, alpha, then they both rest on equal chords. That is to say, AB equals to CD because of the fact that both those peripheral angles rest equal to each other. So they rest on the same on equal chords. That is to say, AB equals to CD. Okay, so from rule number 3, we can deduce that because of the fact that this angle is beta and this angle is also beta, that MD equals to BC because equal peripheral angles rests on equal chords. That is to say, MD equals to BC because both of those angles are beta. Okay, so according to rule number 3, BC equals to MD, but we know that BC equals to 5 units. It is given us in the question. So we can deduce from it that MD also equals to 5 units. That's all. Okay, so we actually have the right triangle ADM. And in this right triangle, we know that side AD equals to 10 units, side MD equals to 5 units, and AM is the diameter of this circle that equals to 2 times the radius. So we can implement the Pythagorean theorem in order to find out the variable D, the hypotenuse of the right triangle ADM. So according to Pythagorean theorem, in a right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Okay, so actually it means that AM square equals to AD square plus MD square. But we know that AD equals to 10, MD equals to 5, and AM equals to D. So we can put the data in equation number 3, and we got that D equals to root of 125, and 125 equals to 25 times 5. We can separate the root to 2 roots, according to rule that root of A times B equals to root A times root B. So we got that D equals to root 25 times 5. The root of 25 is 5. So D, the diameter of the circle, equals to 5 times root 5. But the diameter of any circle equals to 2 times the radius. Okay, so we can substitute D with 5 times root 5 because D equals to 5 times root 5. So 5 times root 5 equals to 2 times the radius. We can divide this equality by 2, and we found out that the radius of this circle equals to 5 times root 5 over 2. And actually the radius of this circle, if we want it in numbers, equals to 5.59 units. Okay, the radius of this circle equals to 5.59 units. Okay, thank you very much.